Welcome to Ramco Institute of Technology. Good morning everyone. Today we are going to see some of the concepts about Introduction to Operating System. I am Mrs. Thulasi Devi, Assistant Professor, Department of IT. So in this lecture we will understand what an operating system is and why it is needed and its goals, components and structure. So this video forms the foundation for the entire subject. So please pay attention. So the next is operating system introduction. First, let us understand what is operating system is. An operating system acts as an interface between the user and the computer hardware. Whenever you use Windows, Linux, Android or iOS, we are interacting with an operating system. It helps us run applications and also manages hardware resources like CPU, memory and devices. So example for this one is when you open a browser, the OS decides how much memory to allocate and when the CPU should execute it. And the next is goals of an operating system. The operating system has three main goals. First, it executes user program like editors, browsers or games. Second, it makes the system convenient to use, so users don't need to know hardware details. Third, it ensures efficient utilization of hardware resources, so nothing is wasted here. So what happens if CPU or memory is wasted? So the answer is system performance reduces, right? Next is computer system components. A computer system consists of four main components. First is hardware, that is CPU, memory and IO devices. And the second is the operating system, which controls the hardware. And the third are application programs like Word, Chrome and media players. Finally, there are users who interact with the application. The operating system is the bridge between hardware and application. The next is user view of operating system. From the user's point of view, the operating system focuses on ease of use and performance. In devices like PCs, laptop and mobiles, users expect fast response and simple interaction. Today, operating systems support touch-based and voice-based interfaces, especially in mobile devices. So, example for this one is voice assistants like Google Assistant work because of OS support. And the next is system view of operating system. From the system's point of view, the operating system acts as a resource allocator. It decides how CPU time, memory, storage and IO devices are shared among processes. The OS ensures fair usage so that no process starves. So in the real-time analogy, think of OS as a traffic police controlling traffic at signals, right? The next is components of operating system. The operating system has two major components. First is the shell, which acts as a user interface. Second is the kernel, which is the core of the operating system. The kernel runs in kernel mode while the application runs in user mode. Important point here is kernel is always resident in memory. Next is interrupt. An interrupt is a signal sent to the CPU by hardware or a software. When an interrupt occurs, the CPU stops its current execution and runs an interrupt service routine. There are two types. One is maskable interrupt, another one is non-maskable interrupt. In maskable interrupt, it can be ignored. The interrupt can be ignored, and in the non-maskable interrupt, it cannot be ignored like memory errors. And the next is the storage structure. Storage in the computer system is divided into primary and secondary memory. So primary memory is RAM, which is fast but volatile. Secondary memory storage includes hard disk and SSD, which are non-volatile. This forms a memory hierarchy based on speed, cost and size. The next is I/O structure. I/O operations are handled using interrupt driven I/O. To improve performance, systems uses direct memory access, that is DMA. DMA allows data transfer without continuous CPU involvement, which improves CPU utilization. And the highlight here is DMA is important for high speed devices. The next one is evaluation of operating system. Operating system have evolved over time. Initially, we had single processor system. Later, came multi-processor system for better performance. And finally, clustered systems were introduced for high availability and reliability. The next one is multiprogramming and multitasking. So multiprogramming keeps multiple processes in memory to keep the CPU busy. Multitasking allows users to run multiple applications simultaneously. These techniques improve CPU utilization and system throughput. Example for this one is listening to music while typing notes. The next is dual mode operation. Operating system uses dual mode operation for protection. In user mode, programs have limited access. In kernel mode, the OS has full access to hardware. This prevents user program from damaging the system. The next is system calls. System calls are the interface between user program and the operating system. They allow programs to request OS services. Examples include fork, execute, wait and exit. Without this system call, user programs cannot access hardware. And the next is OS structure. So operating system can be implemented using different structure. So this includes monolithic, layered, microkernel, modular and hybrid system. Each structure has its own advantage and also has its own disadvantage. So this brings us to the end of this lecture. So thank you for the attention and thank you.